Okay, so I wound a transformer, 29 gauge green wire, 32 gauge orange wire. I made one turn for green and then 2 turns for orange. I kept doing that until I used 75 feet of green wire and 150 feet or maybe 160 feet of the orange wire. So I got a 2-to-1 ratio. And I got it wrapped up, measured the inductance, and the primary, the green one, measured about 330 millihenries, and the red one measured about 1.2 millihenries. So I got it hooked up, but I didn't have a 200 microfarad cap, so this is a 470 microfarad cap. I got a kludged 100 ohm resistor that I made with 3 resistors, and got my little function generator set. If it'll focus. Right now I got 15,000 hertz and duty cycle of 52.7%. So I have a Fluke oscilloscope, PM3380B, 100 megahertz, and the waveform is the big waveform is the secondary, which is the red wire, and the little square wave is the voltage across the resistor. And right now, with a 52.7% duty cycle, I'm getting if it'll focus. I'm getting just a slight negative voltage across the resistor. If I up the duty cycle by 1/10 of 1%, I get a slightly positive voltage across the resistor. So, as you can see on the scope, as I increase the duty cycle, the voltage, DC voltage across the resistor goes positive, and as I decrease the duty cycle, the DC voltage across the resistor goes negative. So right at 52.7%, I get basically 0 volts across the resistor. There's positive 0.6 millivolts. There's negative 0.6 millivolts. That's a change in duty cycle of 1/10 of 1%. So I had to set my function generator. It has an offset, but I couldn't do the offset like TinMan did. And I wish this thing would focus. There we go. So I tried to set the offset, but it only sets in percentage, and when I set it to 100%, it was clipping the waveform. So I set it to 50% duty cycle, and I thought I would get 0 volts, but I think the calibration may be a little off on the thing. Anyway, both my channels are set to DC, which is that little equal sign there next to the channel 1 and channel 2. I don't know if you can see that or not, but anyway, the waveform across the signal generator going into the circuit is a square wave, basically 50% duty cycle, 52.7%, no ringing. Secondary has ringing both at the top and the bottom, as you can see. Now as I change the duty cycle to more positive, the DC voltage on the meter goes up. As you can see, it going up 0.02, 0.03, 0.04. .09, 0.1. So as it goes up, you can see there's a little bit of ringing on the top side of the input waveform, but not much. So as I crank it back down again, positive voltage, when I get into the negative range, so now, oh, by the way, the LED is lit, but it's kind of dim. If I could get it to stay up there. Oh, great. So the LED came off the scope probe, but anyway, as you can see, the LED is lit. Now if I continue turning down the duty cycle and the voltage continues to go negative at a certain percent, the LED starts glowing a lot brighter. So I'm not exactly sure what the explanation for that is. As you can see now, the LED is considerably brighter, and I'm down to 41% duty cycle. So anyway, I do get the ringing that Tin Man observed. I'm increasing the duty cycle. Say I get ringing on the top side. That's at 52%. My meter. Plus, minus 52.7%, 52.8%. So as I turn the duty cycle down, the ringing goes away on the top side. Okay, I got my triggering fixed, and as you can see, the secondary is dropped back down below a little bit, just like on Tin Man's transformer, and they both rise at the same time. You can see a little bit of ringing on the primary, but it's not much compared to the secondary. Okay, this is slowed down to 2,000 hertz. Primary set to 50 to 1 volt per division. because I have a times 10 probe. You can see a little ringing. Secondary is set to 1/2 volt per division, and you can see tons of ringing.